Assalamualaikum, welcome back. So here is metal forming 2 part 1. Let us recap a little bit on the last class. So for the last class, we already looked into the overview of metal forming, what are the metal forming and what are the materials that involve in metal forming, and then the material behavior in metal forming, and then we see the equation like flow stress and also average flow stress, and we also look into the temperature in metal forming, which are cold working, warm working, and also hot working. So in this process, we're going to continue with two topics, which are strain rate sensitivity and also bulk deformation processes. So for the strain rate sensitivity, theoretically a metal when it is hot working, it will behave perfectly plastic. Okay, so with the strain hardening exponent equal to 0, so the metal should continue to flow at same flow stress once the stress is reached. However, that one is the ideal condition. An additional phenomena will occur during the deformation, what we call strain rate sensitivity. This happens usually at elevated temperature. So strain rate is forming directly related to the speed of deformation V, and the deformation speed V is the velocity of the ramp usually. Okay, so this one the strain rate is calculated by using V over H, where H is the instantaneous height of the workpiece being deformed at certain condition, a certain height is being deformed. Okay, so this strain rate is actually the force that acting on the work material when it is being pushed. Okay, so that's why it's very much related to the velocity and also the height of the work material. Let us look into the effect of strain rate on the flow stress. So if we can see, flow stress is YF equal to K epsilon N, right? So where K and N is very dependent to temperature. Okay, so at hot working temperature, flow stress also will depend on the strain rate, not only the K and N, because when temperature is increased, strain rate also will start to increase. So as strain rate increase, resistance to deform also will start to increase. Okay, so this effect of strain rate on strain properties, we call it as strain rate sensitivity. So in terms of the strain rate, it is actually in practical, it is a very complicated process. Okay, so because why it is very dependent on the work part geometry, because we are not creating a one shape like a square or a circle shape only. Usually it is involving part with very intricate geometry. So it is very complicated for the strain rate to be determined, and variation in strain rate, it will be different in region of the part. So the more complicated the part that being created, and then the determination, the evaluation of the strain rate also will be much more complicated. Okay, so strain rate can reach up till 1000 per second. Okay, so which is very big, and this one will give a very good resistance for the deformation. It can be also it can happen in many of the metal forming operation. So as the strain rate is increased, resistance to deformation also will start to increase. So this usually plotted into the straight line on the log graph. So this one will lead into the equation of YF equal to C epsilon dot epsilon n with the power of m, where C is the strain constant and m is the strain rate sensitivity exponent. We're going to see how the C and M is obtained in this equation. Now here is the plot of the flow stress over the strain rate. If you can see, this is the graph. So when we get the C value, it will become at 1.0, it will become like this one. Okay, so in order to get the M value, it is plotted as the log coordinate. Okay, for the flow stress and also the strain rate, it will become like this. Okay, so you will get the M value based on the slope of the graph. So the constant C is actually indicated by the intersection of each plot with the vertical dashes line at strain rate equal to 1. So if we put it here, let's say if you can see the value of the graph inside here when it is at room temperature, the flow stress at 400 degrees Celsius and 800 degrees Celsius and the 1200 degrees Celsius. If you can see flow stress over the strain rate graph, it will become steeper. Okay, so the slope will become much higher. Okay, so compared to the room temperature, which is more to flat one. Okay, so when we put the to get the C value, it is taken at strain rate 1.0 for all the temperature here. So you will see that the C value will increase when it is at room temperature and will start to decrease when it goes down to the bottom, okay, to the 1200 degrees Celsius. Okay, in here also you will see that the M, which is the slope of the plot here. Okay, so if it is the slope, it will become increase. Okay, so if you can see, it becomes steeper when the temperature is increased. So some observation have been made on the strain rate sensitivity. So it says that increasing temperature will decrease the C value and it will increase the M value. So at room temperature, effect of strain rate is almost negligible. So you don't have to calculate the strain rate, okay, when it is the at room temperature, meaning in cold in cold working, it is almost negligible. So flow curve alone is a good representation of the material behavior. So when the temperature will increase, strain rate will become increasingly important in determining the flow stress. Now let us see the calculation for the strain rate here. So a work part with the starting height is 100 and diameter equal to 55 mm is compressed to final height of 50 mm. During the deformation, the relative speed of the platens compressing the part equal to 200 mm per second. Determine the strain rate at H equal to 100, H equal to 75 and H equal to 51 mm. Okay, so as we know, the strain rate is calculated by V over H, right? So V is given 200 and then the one that we are changing is only H value. So the first one is at 100. So you will see that the value is 2.0 per second. And when it is decreased to 75 mm, the value become 2.667 per second, and the last one at 51, it will be 3.922 per second. So meaning that once the height of the product is reduced, okay, so it will become harder for the deformation to take place because of the increasing strain rate. Okay, so there will be additional forces acted, a more strain rate on the work material because of this reduced height. As I've mentioned previously, bulk deformation process in metalworking, we can classify it into four. There are rolling, forging, extrusion, wire, and lastly wire and bar drawing. As I mentioned previously in the bulk deformation, so in this process, there will be significant changes of the final product, okay, from the initial form. Okay, the starting form will be usually cylindrical bar or billet, and then rectangular billet slab and similar shape. Okay, so like the one that I show inside the picture here. Okay, so this process stress the metal sufficiently to cause plastic flow, so then it will change into desired shape after the plastic deformation. So it will be performed cold, warm, or hot working. So why bulk deformation process is important is because in hot working we can significantly shape change, and then we can also perform in the cold working where the strength will be increased for the work material, and then there will be little or no waste at all for the operation. So this one is the most important advantages compared, because if you compare it to the casting and also to the machining particularly, but deformation will give very little waste or no waste at all in the process. Okay.